Hello friends, and welcome to Webronaq. Here is a question worth asking right now. Why would you build your own NAS when you can just buy one off a shelf? Because right now, in mid-2026, HDD prices have surged roughly 40 to 50% in less than a year. The reason is straightforward. Western Digital and Seagate sold their entire 2026 hard drive production capacity to AI data centers, leaving almost nothing for consumers. WD CEO Irving Tan confirmed the company's capacity is fully allocated through calendar year 2026. That squeeze hits pre-built NAS boxes hardest, because they lock you into their drives at retail prices. In this video, we will build a capable 4-bay Linux NAS from scratch, running real open-source software for far less than any lockdown Synology, and you will own every layer of it. Let's get into it. Alright, so what exactly is a NAS? NAS stands for Network Attached Storage. Think of it as a small, always-on Linux computer that sits on your home network and does one job really well: serving files and protecting data. Unlike a plain external USB drive that only works when plugged into one machine, a NAS is accessible to every device on your network simultaneously. Your laptop, your phone, your desktop, they all connect to it at once. But a modern Linux NAS does more than just store files. It runs Docker containers, so you can host a media server, a home automation hub, or a monitoring dashboard right on the same box. It also layers in redundancy, meaning if one drive fails, your data survives. That combination of network access, containerized apps, and data protection is what separates a real NAS from a simple external hard drive. Next, let's pick the hardware. Now look at this. For the compute platform in 2026, the clear sweet spot is a 4-bay mini PC built around an Intel N100, or its direct successor, the N150. These are the same Alder Lake N efficiency class chips. Both have 4 cores, a 6-watt thermal design, and Intel QuickSync for hardware video transcoding on the side. A turnkey 4-bay barebone from brands like AOOSTAR runs roughly $370 to $400 right now. You add 16 gigabytes of DDR5 RAM and your own drives. The reason 16 gigs matters we will explain in a moment when we cover ZFS. The power story is excellent. Measured at the wall with all 4 drives spinning, these systems idle around 14 to 19 watts total. That is less than a light bulb, running 24 hours a day, 7 days a week. This platform beats a comparable Synology unit on price and gives you complete software freedom. Up next, which operating system do you actually put on it? Here's the interesting part. Picking the right operating system changes everything. As of July 2026, 3 platforms dominate. First, TrueNAS Community Edition 25.10.4, codenamed Goldeye, dropped June 3, 2026. It is ZFS native from the ground up, making it the strongest choice for a storage-focused build. Second, OpenMediaVault 8, codenamed Synchrony, is the current release after version 7 reached end of life in June 2026. It sits on Debian 13, uses the least RAM of the 3, and is great if you want a simple, lightweight setup. Third, Unraid 7.3.0, released May 12, 2026, is the paid option, starting at $49, and its big win is mixing drives of different sizes in one array without reformatting. For our 4-bay ZFS build, TrueNAS CE is the clear pick. It has the deepest ZFS integration and the most active release cadence right now. So let's talk about why ZFS matters so much. Alright, let's talk about ZFS and why it is not optional for a serious NAS. A traditional Linux file system like X4 has no idea if the data it stored 6 months ago is still intact. Bit rot, which is silent, undetected corruption from failing drive sectors or memory errors, can quietly destroy your files. ZFS solves this by storing checksums for every single block of data and verifying them on every read. If corruption is found, and you have redundancy, ZFS repairs it automatically. That redundancy comes from RAID-Z1, which tolerates 1 drive failure across your 4-drive pool, or RAID-Z2, which tolerates 2. On top of that, ZFS takes automated snapshots, point-in-time copies of your data that cost almost no extra space. Now there is a persistent myth that ZFS needs 1 gigabyte of RAM per terabyte of storage. That is outdated. On TrueNAS CE 25.10.4, 16 gigabytes of RAM comfortably handles a 4-bay array of 24 to 40 terabytes. That is exactly why we spec 16 gigs in our hardware. Next up, making that pool accessible to every device on your network. Now look at this. You have a ZFS pool full of data. You need to actually reach it from your devices. On TrueNAS CE 25.10.4, you set up Samba, also called SMB, to expose shares to Windows machines. Linux clients connect via NFS. Both are configured through TrueNAS's web interface in a few clicks. But you do not stop there. You lock everything down with UFW, which stands for Uncomplicated Firewall. UFW lets you allow only the specific ports your services need. port 445 for Samba, port 2049 for NFS, and nothing else from the outside world. Then you add WireGuard VPN. WireGuard is a modern, lightweight VPN built into the Linux kernel. You open one UDP port on your router, port 51820 by default, and you now have encrypted remote access to your NAS from anywhere without exposing SMB or NFS to the open internet. Firewall rules plus VPN is the security baseline every home NAS should have. And now for the final, most important layer of all. Let's bring it all together. Your full stack is an N100 or N150 mini PC, TrueNAS CE 25.10.4, a ZFS RAID-Z1 pool across 4 drives, Samba for Windows, NFS for Linux, UFW for firewall rules, and WireGuard for remote access. That is a genuinely capable, secure, self-hosted NAS for well under what a Synology with the same drive count would cost you. But here is the critical takeaway, and please remember this. RAID is not a backup. RAID protects you from a single drive failing. It does nothing for ransomware, accidental deletion, fire, or theft. The rule you need is 3-2-1. Keep 3 copies of your data on 2 different types of media, with 1 copy stored offsite. A service like Backblaze B2 covers that third offsite copy automatically. Build the NAS, run the ZFS pool, and then implement 3-2-1 on top of it. That is your complete protection story. Thanks for watching Webronaq, and we will see you in the next one.